In this video, we will investigate two more properties of exponents. Our first property involves finding a power of a product. Let's look at the equations shown on the slide to understand this property. Notice that in all cases, we're raising a base to the third power. So for example, n cubed is n times n times n. Similarly, the quantity 2x cubed is 2x times 2x times 2x. And if we wanted to simplify this expression further, we could first apply the commutative and associative properties to reorder and regroup all these factors. So we could write 2 times 2 times 2 times x times x times x, or 2 cubed times x cubed. And then our final answer would be 8x cubed. In the same way, if we look at our third equation, the quantity 3y cubed is 3y times 3y times 3y, and we could reorder those factors. And then using exponential notation, we would have 3 cubed times y cubed, or 27y cubed. Let's look more closely at the step just prior to these final simplified answers. Notice that we have two factors, 3 and y, or 2 and x, each being raised to the power of 3. And if we compare that back to the original problem, we see that those are the two original factors in our product that was being raised to the power. So we can see that this process suggests a rule for raising a product to a power. To raise a product to a power, we raise each factor to that same power. This can be expressed algebraically as follows. The quantity ab to the power of n equals a to the power of n times b to the power of n. Our second property is very similar. It involves finding the power of a quotient. Once again, look at the three equations shown on the slide. N cubed is n times n times n. So a quotient, such as 2/3 cubed, would be 2/3 times 2/3 times 2/3. We use that base 2/3 as a factor 3 times because of the exponent. Simplifying further, we would have 2 cubed over 3 cubed, or 8 over 27. And similarly, in our third equation, we have the quantity x over y cubed. That's x over y times x over y times x over y, or x cubed over y cubed. And we can see if we compare the problem to the answer once again that we've actually raised both the numerator and the denominator to that same original exponent of 3. So this process suggests a rule for raising a quotient to a power. To raise a quotient to a power, raise the numerator and the denominator to that power. And this can be expressed algebraically. The quantity a over b to the nth power equals a to the nth power over b to the nth power. Now let's use these properties to simplify some expressions containing exponents. In problem 1, we have the quantity 5a to the third power. Since it's a product raised to a power, we can raise each factor to that same power. 5 to the third power is 125. And so we have 125a cubed as our answer. In problem 2, we have the quantity negative 4n to the fourth squared. So in this case, we need to raise negative 4 to the second power, and then also n to the fourth to the second power. Well, negative 4 times negative 4 is 16. And then now we can apply the power rule to multiply the exponents, 4 times 2, and obtain n to the 8th. So our answer is 16 n to the 8th. In problem 3, notice that our product, negative 3x squared y, actually has 3 factors, and then that product is raised to the power of 3. So we take each of those 3 factors, negative 3x squared and y, and we need to raise all of them to that third power. Negative 3 cubed would be negative 27. X squared cubed, applying the power rule, would be x to the 6th, since we multiply those exponents. And then we have y to the third. So our answer is negative 27, x to the 6th, y to the 3rd. The next three problems involve raising a quotient to a power. In problem 4, the quantity n over 6 squared would be n squared over 6 squared, raising the numerator and denominator to that same power. So our answer is n squared over 36. In problem 5, once again, we raise the numerator and the denominator to that power of 3. So we have x to the 3rd over y to the 5th to the 3rd. So in our numerator, we have x to the 3rd. In our denominator, we multiply the exponents, 5 times 3, and we have y to the 15th. Finally, in problem 6, again, we have a quotient raised to the 4th power. In this case, if we raise the numerator to the 4th power, that numerator is actually the product of a cubed and b. And if we raise the denominator to the 4th power, that denominator is also a product of 2 and c squared. So now we can apply the rule for raising products to a power, and we would have a to the 3rd to the 4th times b to the 4th in the numerator, and 2 to the 4th times c squared to the 4th in the denominator. Lastly, we can apply the power rule. So we have a to the 12th, b to the 4th in the numerator. In the denominator, we have 2 to the 4th, 16, and c squared to the 4th would be c to the 8th. So our answer is a to the 12th, b to the 4th, over 16, c to the 8th.